Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. We were discussing about the chemical kinetics topics, right? Yes, we have completed 4 lectures of chemical kinetics and mostly we've discussed all the topics, right? Yes, there are a few little things yet to be discussed. Those will be discussed in this particular lecture, and then we'll be practicing a lot of questions because in physical chemistry, practice is the key to success, right? Yes. So let's start. What are we going to discuss today? Today, my dear students, we'll be discussing the left part of the Arrhenius equation. There is a very small part which is left. We'll discuss that. And then we'll talk about the catalyst and then we'll practice a lot of questions, right? Yes. So let's start the session, my dear students. So when I talked about the Arrhenius equation, I hope all of you remember we last plotted graphs of the Arrhenius equation, right? Yes. ln versus 1 upon t, then log 10 k versus to 1 upon t. Those were the graphs which we discussed, right? Yes. Now, my dear students, I just want to revise a little portion and then we'll start something new. So, if we talk about the Arrhenius equation, so if we talk about the Arrhenius equation, my dear students, the equation was K is equal to A e raised to the power minus EA by R t. So now, my dear students, I hope all of you remember that when we talked about this particular equation, we said that this little K, that is your rate constant, actually depends on temperature. If you will change the temperature, your rate constant will definitely change. But you have two Arrhenius parameters. Let me write it. Arrhenius parameter. And what are those two parameters? Your two parameters are EA, which was your activation energy, and you had A, which is your Arrhenius constant or pre-exponential factor, right? These two, my dear students, are independent of temperature. They don't depend on temperature. So you need to understand this, that do not depend on temperature. So if I change the temperature, these two particular factors will not change. Okay, this is the most important thing that we need to understand. Now let's try to consider a particular reaction. We'll be talking about only one reaction and we'll be considering it in at two different temperatures. We'll be considering only one reaction at two different temperatures. Okay, so let's try that, my dear students. Let me tell you that we have a reaction A to B. This is your reaction, your elementary reaction, because we know that Arrhenius equation is valid only on the elementary reactions. And let's say that it has a rate constant, some K. Let's write it here. Okay, so here, my dear students, let's take case 1, which is at temperature T1, and let's take case 2 at T2 temperature. Okay, so once the same reaction, you have T1 temperature and T2 temperature, two different temperatures, my dear students. If these are two temperatures, then I can say that K1 will be, this will be K1 and this will be K2. That is, your rate constant depends on temperature, so definitely the value of K1 and K2 will also be different. I also told you that activation energy and your pre-exponential factor doesn't depend on the temperature. So your activation energy EA, here will be EA and it will be here also EA. It will be a Arrhenius parameter A and it will be Arrhenius parameter A, right? Yes. So now let's try to write the Arrhenius equation in both the cases. Okay, so now we'll be writing the Arrhenius equation in both the cases. K1 will be equal to A e raised to the power minus EA by RT1, right? I hope you don't have any issue till now. Let's write for the other part. K2 will be equal to A e raised to the power minus EA by RT2. Okay, clear? Yes, perfect. Now, my dear students, your K1 is A e raised to the power minus EA by RT1. Your K2 is A e raised to the power minus EA by RT2. Can I say that this is your first equation and this is your second equation, and let's divide first equation by second. you will get K1 is equal to A e raised to the power minus EA by RT1 divided by K2 is equal to A e raised to the power minus EA by RT2. Right? Yes, perfect. So we can cancel out A because it doesn't depend on temperature. The value will be same. Perfect. Now I can say that K1 upon K2 will be equal to e raised to the power minus EA by RT1 upon e raised to the power minus e raised to the power minus EA upon RT2. Okay, yes. Can I take this power? These both are powers of E. So can I take this power in the upper part? Yes, it would be E minus EA by RT1 plus EA by RT2. Right? Yes, perfect. So your K1 by K2 came out to be e raised to the power EA by RT2 minus EA by RT1. Okay, till now I hope everything is clear. Yes, perfect. Now my dear students, I'll take EA upon R common. So K1 by K2 will be equal to e raised to the power EA by R 1 upon T2 minus T1. So 1 upon T2 minus 1 upon T1, right? Yes, this is a very important expression. This is a very important expression, right? Where we can see the temperature dependence of K1 and K2, or we can say that we can relate K1 and K2 at two different temperatures, right? Yes. So this is an important expression which you need to understand how is it derived. I hope till now everything is clear. Now what are we going to do? Now we'll be taking log. We'll just continue this derivation. We'll take log of this particular. So let's take log on both sides. So taking natural log, taking ln on both sides, what will we get? Ln of K1 by K2 is equal to ln of e raised to the power EA by R 1 upon T2 minus 1 upon T1. Now, my dear students, I want to tell you a property which we'll be using. In fact, we've used this property, so you might remember that as well. But let me just jot down your memory here. Whenever you take ln of e raised to the power x, it is actually equal to x. Whenever you say ln e raised to the power x, it is actually equal to x. So since it is ln e raised to the power this, so I can say that ln of e raised to the power will be equal to this. So let's just use this, and we can say that ln of K1 by K2 is equal to EA by R 1 upon T2 minus 1 upon T1. Again, a very, very important relation. Now I'll make you understand that why the temperature, as the temperature increases, your rate constant actually increases. This particular expression will make you understand that. Okay, so this is important for you. So if you want to write it, please write it. This is the most important derivation. It is not a derivation. If you have understood the things, then you need not, memorize it. You just need to understand the concept. Okay, perfect, my dear students. So just write it. I took K1 and K2 at two different temperatures. I wrote their expressions. I just divided them and did a little of the maths. Pause the video, write it. Pause the video, write it. Okay. Now, we'll be using this particular expression to understand a few things. Okay. So, just see it. Now, I'll write the expression. Ln of K1 by K2 is equal to EA by R 1 upon T2 minus 1 upon T1. Okay. This is the expression. Now, my dear students, let's take a few cases and understand this a little more. Let's take case 1. I am saying you that I don't know K1 is more or K2 is more, but I know that in temperature, my dear students, let's say T2 is more than T1 temperature. Let's say T2 temperature is more than T1 temperature. Perfect. Yes. So if your T2 temperature is more than T1 temperature, then what will happen? Okay. If I say T2 is more than T1, then my dear students, can I say that? Just a second, my dear students. Okay. So now, my dear students, if we see, we can say that, let's take the case that your temperature 2 is more than temperature 1. So if your temperature 2 is more than temperature 1, my dear students, then what will happen? Ma'am, if we write this expression, this important expression which we have just derived, K1 by K2 is equal to EA by R 1 upon T2 minus 1 upon T1. You just need to understand this. Okay. So now just imagine, my dear students, just imagine if your T2 is more than T1, this means that this whole fraction value, when your denominator is more, see 1 upon 2, my dear students, you have 1 upon 2 and you have 1 upon 3. Okay. When your denominator is a bigger number, when your denominator is bigger, the fraction is smaller, right? So I can say that half is more than 1 by 3. This means that whenever more the denominator, lesser will be the value for the fraction. So if T2 is more than T1, then can I say that 1 upon T2 will be less than 1 upon T1? Yes, ma'am, it will be less than this. Can I say that this whole value will come out to be a negative value? If you will subtract 1 upon 3 minus 1 upon 2, it will give you some negative value. It will give you some negative value. Yes. So exactly like this, my dear students, I just use the concept of math. I haven't calculated it, but I know that this value will come out to be negative. Okay. Your activation energy is always a positive value. And your rate constant is also a positive value. It is never a negative value. I hope you're clear with this. Perfect. So can I say that this whole value, this whole part will always be a negative value? Yes, because this is positive, and anything positive multiplied by a negative value will give you a negative value. So now from here, I can say that ln of K1 by K2 is a negative value. Now you need to understand a very important log expression, and that log expression is whenever in ln is equal to x is a negative value. Ever if now log of something is negative, that means that x is less than 1. This means that x is less than 1. This is the most important thing. ln of 0.2, ln of 0.3, ln of 0.535, ln of 0.234, all the values which are lesser will be negative, which are lesser than 1 will be a negative value. So if I see that ln of x is coming out to be, if anything's natural log value is coming out to be negative, then definitely that is lesser than 1. Okay, I hope you're clear with this. So ma'am, since this is less than 1, I can say that we know that K1 by K2 is less than 1. Because here, my dear students, your x value is K1 by K2. And if K1 is less than K2, can I say that K1 is lesser than K2? So, when your T2 is more than T1, you just found out that your K2 is more than K1. So, more the temperature, more will be the value of rate constant. That is, more the temperature, more the rate constant. This is something you derived on your own. Right? Yes, perfect. I hope you're clear with this. Write this down and then we'll discuss the second case as well. So just write it down. I hope you've written it. Perfect, my dear students. Let's take the case 2. Case 2 is, let's say T1 is more than T2. This time T1 will be more than T2. So let's write the expression again. ln of K1 by K2 is equal to EA by R 1 upon T2 minus 1 upon T1. So now this time, my dear students, I can say that since T1 is more than T2, then definitely 1 upon T1 will be lesser than 1 upon T2. So this overall value will come out to be a positive value. Perfect. No issues till now. Since this is positive and this is positive always, so this overall value will come out to be positive. So ln of K1 by K2 is a positive value. Now since it is a positive value, my dear students, natural log ln of x is positive, this means that your x is always more than 1. Log of 1 is 0, log 2 is positive, more than 1, log 2 is positive, log 3, log 4, all the log values more than 1 are positive, right? Yes. So I can say that from this expression, k1 by k2 is more than 1. So k1 will be more than k2. This is something which you derived right now, and you can say that since T1 is more than T2, your k1 will be more than k2. That is, actually your k value depends on the temperature. Perfect? Yes, I hope you're clear with this. You can pause the video, write it, and then we'll move forward. Okay, so this was all about, my dear students, Arrhenius equation. Okay, yes, perfect. Now let's try to solve a few questions. Let's say you have this question, you have to try this question yourself. It will just revise all your topics. The question says that consider the reaction A to B, graph between initial T half of initial concentration A, how graph between minus dA by dt versus time will be. Okay, so first check this graph. Seeing the graph, you have to find out which order of the reaction is it talking about, and then using that information, you will find out the graph between these two. So this is actually a very good question, and these questions, this type of questions are generally asked. So how are we going to do this? Try it. See, if you see here, you can say that your T half is actually directly proportional to the initial concentration A. And if you remember the expression of T half, you know that in all the expressions, T half is generally inversely proportional to the concentration. There is only one order, which is your zero order reaction, where T half is directly proportional to the initial concentration. The expression is T half is equal to A upon 2K, right? Yes. So seeing this, seeing the graph, seeing the proportionality, I can say that the order of the reaction is 0. It is a zero order reaction. This is something you needed to find out. Now, since the order of the reaction is 0, so you have to find out the graph between minus dA by dt versus time. Now, what is minus dA by dt? I hope all of you remember that the instantaneous rate is given by minus dA by dt. This means that you have to plot a graph between rate versus time. So let's talk about the rate of a zero order reaction. According to the rate law, R is equal to K A raised to the power 0. So rate is equal to K. That is, for a zero order reaction, my dear students, your rate with time is a constant value. Rate doesn't change, right? Yes. So rate is a constant value. So can I say that it will be a constant value? So minus dA by dt versus t will be option C, and that will be your correct answer. This is how you will be solving this type of question. Okay, I hope you're clear with this. Perfect, my dear students. Pause the video, write it, and then we'll move forward. Let's try to solve another question. The question is, you have A2 plus B2, which gives you 2AB. Okay, you are given initial concentrations of A2 and B2, and you are given rate. You have to find the orders. Okay, so you know that how to solve these types of questions. We have tried such types of questions. You have to write the rate law. R is equal to K. A concentration, you have A2 and B2 concentration. Okay, perfect. Let's say order with respect to A2 is A and order with respect to B2 is B. Let's write the equations now. Rate is 0.04 is equal to K into A2 concentration is 0.2 raised to the power A and 0.2 raised to the power B. Then you have 0.04 K into 0.1 raised to the power A and 0.4 raised to the power B. Then you have 0.08 is equal to K, 0.2 raised to the power A and 0.4 raised to the power B. Okay, yes, perfect. Write it down, and then we'll move forward. Okay, perfect. I hope you've written this. These are the three equations which you have derived. So this is your first equation, second equation, and third equation. Okay, Perfect. Now you have to divide, you have to see that take such equations where one of the reactants concentration is equal so that it gets cancelled out. So if I see, I can say that let's take third and first. Yes, let's take third and first. So let's divide third equation by first equation. You will get 0.08 is equal to K, 0.2 raised to the power A, 0.4 raised to the power B divided by 0.04 is equal to K, 0.2 raised to the power A, 0.2 raised to the power B. Right? Yes. So K will be cancelled because as long as the temperature is not changing, the rate constant will not change. Okay. So this will be 1, this will be 2, this whole cancelled out. You can say that 2 upon 1 is actually equal to 0.4 upon 0.2 whole power B, which is equal to 2 power B. So we can say that 2 power 1 is equal to 2 power B. So B value is equal to 1. So order with respect to A is 1. So I can say that with B is 1. So I can say that second is not the correct option. Let's check the order for A. Okay. So for calculating the order of A, we need to cancel out the B concentration. So let's take third and second equation. So let's divide third equation by second. 0.08 is equal to K into 0.2 A. Here it will be 0.4 B. Is it 0.4 B? Yeah, it is 0.4 B. Now let's divide it by second, which is 1 and 4. 0.04 K, 0.1 A and 0.4 B. Right? Yes, again, we'll cancel K and we'll cancel B concentrations because they both are equal. Now, my dear students, this would be 1, this would be 2. So, 2 upon 1 is equal to 0.2 upon 0.1 whole power A. So, which is 2 upon 1 whole power A. So, 2 power 1 is equal to 2 power A. So, A is also equal to 1. So, order with respect to A2 and order with respect to B2 both are 1. And what will be the overall order of the reaction? A plus B, which is 1 plus 1, which is 2. Right? Yes. So let's see which is the correct option. A is 1 and B is 1. So option A will be your correct answer. So this is how you will be solving this types of questions. Okay, perfect. I hope you're clear with this. Perfect, my dear students. Please write it down and then we'll move forward. Okay. Now, my dear students, we'll be starting another topic, which is catalyst. We'll be discussing a very little amount of things about catalyst in this particular chapter, and in detailed discussion we'll be doing in the surface chemistry chapter. So now, when we talk about the catalyst, what exactly is a catalyst? I hope all of you remember I gave you an example when I told you about the activation energy. I told you that you are the reactant and your mother is giving you some activation energy. She's giving you some money, right? Yeah. So what catalyst actually does is it actually changes the rate of a particular reaction. What is a catalyst? It actually alters the rate of a chemical reaction. It either can increase the rate of the reaction or it can decrease the rate of the reaction, but it will change the rate of the reaction. Okay, so first and the most important definition would be catalyst alters the rate of a reaction. So catalyst actually alters the rate of a reaction. Catalyst actually alters, that is, it changes the rate of a reaction. It might increase or it might decrease. I'll give you both the examples. Now imagine what actually happens. What actually happens is catalyst, you know, every reaction has a activation energy, minimum energy which reactants require. What catalyst does is, in order to increase the rate of the reaction, it actually decreases the activation energy. Now, since the activation energy is lesser, so reactants need a lesser amount of energy to to form the products. So obviously the reaction will be faster. Okay, so now let's take the example. Let's take the example of you and your mom. You are actually still fighting over how much money you want. Okay, you said you want 50, but your mother is saying no, 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 I can only give you 40, I can't give you more than that, right? Yeah, I hope all of you have seen your mothers and fathers bargaining over a little those we all bargain. I too bargain a lot. So what we do, the shopkeeper says 50 rupees or 500 rupees for a particular thing, and you will be like, no, 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 I can give you only 300, I can't give you more than that, right? Yeah, so the same way you and your mother are bargaining for the money, and all of a sudden a superhero comes, and that superhero is your father. And now, my dear students, he will act like a catalyst. So what will happen is, he's a little hungry. Okay, so he needs the food to be cooked faster. So what will he say? He'll just shout at you once, and you will be like, oh my god, now I have to go, right? Yeah, your father will shout on you, and he'll say, take the 40 rupees and just go and bring the grocery, right? Yeah, what happened? You had to say yes. So your activation energy, that is your threshold energy, that is the maximum amount, came out to 40. Yes, and this is what catalyst does. Catalyst actually decreases the activation energy, and the activation energy decreases, and the reaction is done. The reaction is faster, right? Yes, so this is the role of a positive catalyst. Now, what happens if it is not a positive catalyst and a negative catalyst? What negative catalyst would do? Negative catalyst actually what a negative catalyst does is, it increases the rate of the reaction. It increases. Let's say a reaction was about to be performed in 2 hours, but a negative catalyst will do something, will give you some path, like the reaction will take place now in 3 to 4 hours. So the rate might increase, and that would the rate might decrease. Yeah, right, rate might decrease. That is the role of your negative catalyst. But generally, when you're not given in the question, you're just said that a catalyst is used, mostly, my dear students, your catalyst is a positive catalyst. Okay, it always increases the rate of the reaction. So this is what a catalyst does. Your father was an example of a catalyst. Also, I can give you another example. Let's say you were hiking somewhere, and this is the mountain that you are supposed to trek. Okay, you need to go at this particular destination. This is your destination, and you are standing here. Okay, so now what will happen? My dear students, you are standing here, and this is your final destination, and you know that you'll have to hike over this whole mountain, and it will take nearly 2 days. Okay, yes, so this is the time that will be required for a reaction to happen, that is for you to reach your destination. But what happens is a person just comes, a person who is a local of that particular area. He comes, and he's like, okay, let me just draw. And he asks you that what are you supposed to do? Well, where do you want to go? And you said that you want to reach this destination, and you are preparing yourself to hike this mountain so that you can reach your destination. Now, the person was good. He was a local person, so he knows the area nearby. So he said that, wait, I'll make sure that I'll take you to this particular place in just 2 hours. And how is that possible? He is a local person, and he knows a local shortcut to reach this destination in just 2 hours. So what happened, my dear students? The time, which was 2 days, had just reduced to 2 hours. What happened? Does your initial destination or your final destination change? Has it changed? No, it hasn't changed. Your initial and final destinations are same, just the path is different. The same way, my dear students, catalyst doesn't change the initial or the final states of a reaction. It only what does is it provides you with an alternate path to reach the destination a little faster. Okay, and this is the role of a catalyst. So he is your catalyst here. He has helped you reach the destination faster. So this is what happens in a chemical reaction. This is what catalyst does. Okay, yes, I hope you're clear with the catalyst concept. Now let's read a few pointers about it. A catalyst can change the rate constant of a reaction at constant temperature. Okay, a catalyst can change the rate constant. Now it will change the rate constant. Eventually the rate of the reaction will change. Okay, it can increase, it can decrease. If it increases the rate constant, it is called a positive catalyst. If it decreases the rate constant, it is called a negative catalyst. Okay, if nothing is mentioned, the question, we assume that it is a positive catalyst. Always consider a positive catalyst. If it is not mentioned, that it is a negative catalyst. Okay, perfect. Let's move forward. Now, catalyst does not change the initial or the final states. I am telling you, take the example, your initial destination and your final destination are not changed. It only provides you a alternate path. Therefore, the change in the thermodynamic state functions, these are the thermodynamic state functions, my dear students. You might have studied about them in the thermodynamics chapters. These actually depend only on the initial and final states and not on the path you have followed. And that is the reason these doesn't change, because your initial and final positions haven't changed, right? Yeah, unaffected by the catalyst. So they are actually unaffected because catalyst actually plays the role during the path and not in the initial or the final state. Okay. Therefore, a catalyst cannot initiate a reaction. Now is the most important thing. Imagine you and your mom were discussing about things, and you somehow, let's take a case where you were so lazy, you were so tired that you didn't want to go to the grocery store. Be it 100 rupees, be it 1000 rupees, you were so tired that you don't want to go. You don't want to stand. Okay. Now, your mom will give you 100 rupees, 200 rupees, 300 rupees, 400 rupees. It doesn't matter. It doesn't matter because you don't want to go. This means that when a reactant does not want to go, or when a reactant is incapable of initiating a reaction, when a reactant is incapable of initiating a reaction, if it does not have the activation energy, he doesn't want to start the reaction, then, my dear students, you take any catalyst, the reaction will not take place. The reaction will not take place. Catalyst can only help those reactants which actually want the reaction to happen. It can only help them by increasing the rate. But if some reactants are such that they do not want the reaction to happen, then catalyst doesn't have any role to play. Okay, yes. So a catalyst can never initiate a reaction. If a reaction is not supposed to happen, then catalyst cannot help it. If a reaction can happen, then it can increase its rate. This is the most important thing. Therefore, a catalyst cannot initiate a reaction. Next. Catalyst participates in the reaction but remains intact at the end. Now see, imagine the person which your friend, which you met at that local village, and he gave you a different path to move, right? Yeah. So what happened was, you said, please take me to the place. So what he did? He said, okay, I'll take you to the place. So you both went together. Okay, and then you reached your destination and the person went back to his place, right? Yeah. So what happened? The catalyst initially went with you. He dropped you at your point and then he just went back to his work. This is what catalyst does. If you have a particular amount of catalyst in the start of the reaction, you'll have the same amount of the catalyst in the end of the reaction. It will not be present in your products. This means that, let's say you have a reaction A plus B. Okay, this is a reaction and you take a catalyst C. So this catalyst will help you perform the reaction and you will get your AB product. But my dear students, your catalyst C will not be present in the products. It will be, if this was 1 molar here in the starting, this will be 1 molar here in the end, and you can reuse this catalyst because it actually does take part in the reaction, but it does not come in the product form. It again and again regains itself and you get the same amount of catalyst in the product side. Okay, so this is what catalyst does. Catalyst participates in the reaction. Yes, it does participate in the reaction, but remains intact in the end of the reaction. Since catalyst appears as a product, it can be reused. Now since it is there, it can be reused, and a little bit of the catalyst is good enough for the reaction. Now different catalysts, reactions need a different catalysts, but that is something to be discussed in the surface chemistry chapter. Okay, yes, I hope you're clear with all the things about catalyst now. If you want to write it, you can write it, and then we'll move forward. Okay, perfect. Now my dear students, if you talk about the types of catalyst, you majorly have two types of catalysts: positive catalyst and you have a negative catalyst. It increases the rate of the reaction and this decreases the rate of the reaction. Okay, so this is something that you need to understand. Rest all we'll discuss in detail in the surface chemistry chapter. Okay, yes, perfect. Please write it and then we'll move forward. Okay, I hope you've written it. Okay, let's move forward. Now, my dear students, we'll solve questions. Now the topic is completed. Okay, now we'll solve questions and see how different types of questions are generally asked. Okay, so the first question on your screen is, now there will be a lot of practice questions, so you need to make sure that whenever you see a question, pause the video, try the question yourself, and then see ma'am's approach. Okay, so what does the question say? The question says that initial mole is given as, initial rate is given as this. So your initial rate is given as K, A raised to the power 2, B raised to the power 1. By what factor initial rate will increase if the initial concentration of A is taken 1.5 times and B is tripled? Okay, so let's see what happens. It says that the concentration A dash, you change the concentration of A to 1.5 times of A, and you change the concentration of B as 3 times of B. Obviously, when you will change the reactant's concentration, your rate of the reaction will definitely increase or decrease. I would say it will change. So this would be R dash. This would be K into A dash whole power 2 and B dash whole power 1. This would be K into A dash is 1.5 A and B dash is 3B. Okay, power 1. This would be 1.5 whole square K into A 2 and this would be 3 and this would be B. So I can say that 1.5 whole square into 3 into K into A whole power 2 into B. Just see, my dear students, just see. This actually is your R rate. So can I say that? Your R dash is actually equal to 1.5 whole square into 3 into rate. So R dash is equal to, let's now multiply it. This would come out to be, I guess, 15, this would be 225. I think option 3, 6.75 R would be your correct answer. So R dash would be 6.75 R. That is option 3 will be your correct answer. Right? Perfect. Pause the video, write it, my dear students, understand how have we solved this question, and then we'll move forward. I hope you've written it. Now let's move forward. Let's try the another question. The another question is on your screens. Try the question yourself. The question says that for a elementary reaction, this is a elementary reaction, my dear students, elementary reaction, X2Y plus Z, half-life period is 10 minutes. Okay, so since this is an elementary reaction, my dear students, can I say that I can see that since it is an elementary reaction, molecularity is 1 and that is the order. So the order of the reaction is 1. Okay, this is how you have to find out that what is the order of the reaction. Okay, now half-life period is 10 minutes, so you are given T half equal to 10 minutes. In what period of time would the concentration X be reduced to 10%, okay, of the original amount? So it says that your final concentration should be 10 upon 100 of initial amount. So this is something A naught by 10. So I can say that initial amount is A naught and your final amount is A naught by 10. It decreases to 10% of the initial amount. I know that integrated rate law. First, from integrated rate law, T half is equal to ln of 2 by K. So can I say that K is equal to ln of 2 by T half, which is 10 minutes? Right? Let's write the integrated rate law. Let's write the integrated rate law, my dear students. Your K is equal to, let me use another pen. Your K is equal to 2.303 upon T log A naught upon A T. Right? Yes. K value is ln of 2 by 10. This is 2.303 by T log A naught upon, what is AT value? AT value is A naught by 10. So this is something A naught divided by 10. So this would be 10. So let's cancel this out. If you talk about natural log 2, can you write it as 2.303 log base 2? Yes. Log base 10 2? Yes, ma'am. So this is 2.303 log 2 upon 10 is equal to 2.303 log 10, and here it is T. So let's cancel this out here. Now, my dear students, log 2. What is log 2? I'll just make you understand this also. So I can say that log 2 value is actually 0.3. Log 2 is actually equal to 0.3 value. Okay, yes, upon 10 is actually equal to 1 upon T. So T is equal to 10 upon 0.3, which is equal to 100 upon 3. So this would be 33.3 minutes. So is this option 33.3 minutes? Yeah, 33 minutes. So option 2 will be your correct answer. So this is how you will be solving these questions. You just need to understand what the question is trying to tell you and solve the question. Perfect. Yes, I hope you're clear with this. We have used all the things that we have discussed about the first order in this particular question. I hope you're clear with this. Now let's move forward, my dear students. Let's see what is the next question. You want to write it, you can write it. Next question. The question says that A plus B gives you C and the rate is given by A power half and B whole square. Initial concentration of A and B are increased by a factor of 4 and 2. So this means that your A dash concentration is 4 times of A and your B dash concentration is 2 times of B, and you are given the rate. You have to tell the final rate is how many times of the initial rate. Okay, so your initial rate would be R is equal to K, A power half and B power 2. So my dear students, R dash will be K, A dash power half and B dash power 2, right? Yes, this is K. What is A? 4 raised to the power half. This would be 2B power 2. Let's try to solve this. Okay, this would be K into, now see, 4 power 1 by 2. Can I say that it is equal to 2? Root of 4 is 2. Yes. So this would be 2 times of A power half. Then you have 2 to 4 times. Then here will be B. So this is 2 into 4 K A power half and B power 2. Just check it out. This is equal to your rate, initial rate R. So R dash is equal to 8 times of R. So your final rate is 8 times of the initial rate. So 8, that is option 3 is your correct answer. This is how you have to solve these questions. You need to be very clear about everything, right? Yes, perfect. I hope you got this. Please write it and then we'll move forward. Now try to do this question. Which of the following represents the expression for 3/4 life of first order reaction? Now, see, if it is telling you that it is the 3/4 life, this means that 3/4 of your reaction has taken place. That is 3/4 of your amount of initial reactant has been consumed. So, how much amount of your reactant is left? Only 1/4 is left. And what is 80? 80 is initial minus how much amount has been consumed? 3/4 of initial amount. So this is 1/4 of initial amount is left, and A naught is your initial amount. So from integrated rate law, I know that T is equal to 2.303 upon K log A naught upon A T. This would be 2.303 upon K log A naught upon A naught. Here it will come out to be 4. So I can say that T is equal to 2.303 upon K log 4. So 2.303 upon K log 4. This means that option 3 will be your correct answer. Such easy questions, you just need to understand the concept. You will be able to solve each and every question yourself. Okay? Perfect. I hope you're clear with this. Please write it and then we'll move forward. Let's try another question. Okay, I think we've done this question. This question is done. So let me just delete it. Next question, my dear students. Just see the question. The questions are super easy. You just need to understand what are they asking. The question says that from the rate expression from the following reactions, determine their order of the reaction and dimensions of the rate constant. Okay. So you have to tell the order and you have to give the unit of rate constant. Let's see the first reaction. If you see the first reaction, you are given the rate law. If you are given the rate law, just see the power of NO. It is 2. So the order of reaction is 2. And what will be the rate constant? Mole 1. What is the unit? I'll write it here and just put the values. K is equal to mole 1 minus n, L, n minus 1, second inverse. So if your order is 2, just put the n value 2. Okay. I can say that for first, n is equal to 2. So just put it down here and you will get your answer. Perfect. Let's do the second part. You are given the rate. The rate is 1 H2O I negative. So this is 1, this is 1. So the order, overall order again is 2. So again the rate constant, you will just put the values here. Third, my dear students, you have CH3, CHO and the order is given to be 3.2. 3 by 2. So your n value here would be 3 by 2. So easy. So easy question, right? Yeah. Next. You have C2H5L, that there is 1, so the order is 1. Just put the n value in the general expression and you will get the rate constant values as well. Okay, perfect. I hope you're clear with this. Pause the video, write it. I hope you've written it. Now let's move forward. Next question. Let's see what the next question says. The next question says that the decomposition of NH3 on platinum surface is 0 order reaction. So you are given the order of the reaction is 0. Okay, so n value is 0. What are the rates of production of N2 and H2 if R is this? Okay, so now my dear students, you are given the decomposition of NH3. So when you talk about NH3 decomposition, so the reaction is N2 plus H2. Let's just balance it out here. 2, so this is 2, you have, yeah, this is your balanced reaction. So now you are given the rate of the reaction R is equal to 2.5 into 10 raised to the power minus 4, and you have to tell that the rate of production of N2 and H2 is. So you have to give the rate of production of N2 and H2. This means that you have to give d of N2 by dt value, and also you have to give the value of d of H2 by dt. These are the values which you are supposed to calculate. Okay, so how are we going to calculate? See, my dear students, in the start of the chapter, when we started this chapter, we saw that whenever you are given a reaction, you say that the rate of the reaction is given by plus of 1 by 2 d NH2 by dt. No, not plus, this would be minus because this is your reactant, right? Yes, and this is actually equal to plus of d of N2 by dt plus of 1 by 3 dH2 by dt. Okay, so now whatever you have to calculate, just use those two expressions. Now you have to calculate d of N2 by dt. Okay, so this means that you will use this expression and you will use this expression, right? Yes, because you are given the rate for the production of N2 and H2 if R is this. You are given the rate, you are given R value, you can use this. You can say that R is actually equal to d of N2 by dt. So the value would be 2.5 into 10 raised to the power minus 4. So this is the correct answer. Next is you have to calculate for H2 as well. Okay. So for H2, what all you will compare? You will compare this rate with this part. Okay. Yes. So can I say that R is equal to 1 by 3 dH2 by dt? Right. This means that 3 into rate will be equal to d of H2 by dt. Right? Yes. So d of H2 by dt will be equal to 3 into 2.5 into 10 raised to the power minus 4. Just multiply it. 5, 3, 15, 5, 1, 3, 2, 6, 7. 7.5 into 10 raised to the power minus 4. So this is your correct answer. So this is how you will be solving these types of questions. Just understand what is asked. You only have to use the things which we have already discussed in the class. Okay. I hope you're clear with this. Perfect, my dear students. If you want to write it, you can write it and then we'll move forward. Next question. The question is, a reaction is a second order with respect to a reactant. Your reaction is a second order with respect to a reactant. So your reaction is, let us say, Ka, and it is second order with respect to the reactant. Rate of the reaction affected. If you double the concentration, so your first case is your A dash concentration is 2 times of A. So can I say that R dash would be equal to K into A dash whole square, which is K into 2A whole square, which is equal to 4K into A whole square, which is actually equal to 4R. So the rate actually becomes 4 times. Okay, let's talk about the second part. Reduced to half. So now, my dear students, your A dash concentration is A by 2. So your R dash would be equal to K into A dash whole square. So K into A by 2 whole square. This would be 1 by 4 K into A whole square. Right? Yes. So this is R by 4. So the rate actually becomes 1/4. So the rate actually becomes 1/4. So this is how you will be solving this types of questions. I hope you're clear with this. Perfect, my dear students. Let's move forward. Okay. Next question. The question is on your screen. In a pseudo first order reaction, your reaction is a pseudo first order reaction. The following results were obtained. You are given the time and the concentration of the reactants. You have to calculate the average rate of the reaction between the time interval 30 to 60 seconds. You have to calculate the average rate. I know how to calculate the average rate. The final concentration minus initial concentration upon T final minus T initial. So easy, right? You are given the time intervals. You are given the time between 30 to 60 seconds. Let's see what is the concentration. And since it is for reactant, so you will have to put a negative sign. For 60 seconds, it is 0.17 minus, for 30 seconds, it is 0.31 divided by 60 minus 30. Just subtract it. You have 11 minus 7. This will be 4. Then you have 2 minus 1, 1. Okay. Then you will have 0 point this divided by 30. Right? Yes, perfect. Just solve this and you will get your answer. I hope you're clear with this. Please pause the video, write it, and then we'll move forward. I hope you've written it. Now let's move forward, my dear students. Let's see the next question. The next question says the reaction is first order in A and second order in B. So you have a reaction which is first order in A, that A1, and your second order in B. Okay, yes. What? Write the differential rate equation. So you have written the differential rate equation. Can you write R is equal to minus, just a second. Acha. First we have to write the reaction for this. Na? So the reaction would be A plus 2B gives you some products. So you have to find the differential rate equation. So R would be equal to minus dA by dt minus 1 by 2, and this is equal to minus 1 by 2 dB by dt. Right? Yeah, perfect. First, you have to write the differential rate equation. The second is how is the rate affected on increasing the concentration of B 3 times. Now, if you increase the concentration of B 3 times, so your second case, your B dash would be 3 times of B. So your R dash would be K into A. A is intact, it is same. B is 3 times of B whole 2. So 3, 3, 9. So 9 K A B whole square. So can I say that R dash is actually equal to 9 times of R? Yes. So the rate increases 9 times. Perfect. Yes. Let's see the third part. How is the rate affected when the concentration of both A and B are doubled? Now what will happen if the concentration of both A and B are doubled? R dash is equal to K A 1 B whole square. Now your A dash is 2 times of A and your B dash is 2 times of B. So your R dash would be equal to K into 2A power 1 and 2B power 1. This would be 2 into 2 to, this is 2 na, 2 to 2 4 K A power 1 and B power 2. This would be 8 K A power 1 B power 2. So your R dash would be 8 times of R. So your R dash would come out to be 8 times of R. Right? Yes. So it will be 8 times of the initial rate. I hope you're clear with this. Perfect. So pause the video, write it, and then we'll move forward. Next. I hope you've written it. Perfect. Let's move to the next question. The next question says that in a reaction between A and B, the initial rate of reaction was measured for different. Okay. So this is your homework question, my dear students. We just did a question exactly like this. You have to make 3 equations and then you will have to try and take 2 such equations where you can cancel one of the reactants concentration and you will find the order with respect to one reactant, and in the other 2 set of reactions you will find out the order of the other reaction. Okay. So this is how you will be solving these types of questions. I hope you're clear with this. Perfect, my dear students. Now we can move forward. Okay. Calculate the half-life of a first order reaction. You have to calculate the half-life of a first order reaction from their rate constants given below. Okay. Yes. So first is 200 second inverse, second is 2 minute inverse, fourth is 4 years inverse. So my dear students, for a first order reaction, we know that T half is equal to ln of 2 by K, or we can say that K is equal to ln of 2 by T half, which is 0.693 upon T half. Right? Yes. You have to calculate the half-life. Okay, you have to calculate the half-life. So T half will be equal to 0.693 upon K. Okay, so now let's calculate. You only have to put the values here. You know the K values are these. So T half for this will be, T half for this would be 0.693 upon 200. The answer would come out to be in seconds. Here T half would be 0.693 upon 2 minutes. The answer would come out to be in minutes. And here T half would be 0.693 upon 4 and the answer would come out to be in years. Perfect. Yes, such easy questions are asked and you have to solve these questions. So easy questions, right? Yes, you cannot miss even a single question. Perfect. I hope you're clear with this. with this, my dear students, we end our session. We end our chapter today. I hope you are clear with all the topics we have discussed in chemical kinetics. I hope you have solved all the questions yourself, because that is the most important thing. I have tried to make you understand each and every topic to the best, and I hope you are also studying, you are also practicing questions, because in physical chemistry you need to practice a lot. Okay, yes, so stay motivated, stay happy, stay positive. We'll meet in the next session with another chapter. Till then, keep studying. All the very best. Thank you so much.